numbers. So real numbers means, first, what is real numbers? Both rational and irrational number together we call it as a real numbers. Okay, both rational and the irrational numbers together we call it as the real numbers. So rational numbers means what? P, which you can write in the P by Q form, which you can write in the P by Q form. Okay. Okay. Rational numbers are the one which you can write in the P by Q form. Irrational numbers are the one which you cannot write in the P by Q form, which you cannot write in the P by Q form. Okay. So real numbers is about these rational and the irrational numbers together. Okay, so how we will know irrational number? For example, we have root 2. Okay, for example, if you have root 2, so root 2 root 2, you cannot write it in the P by Q form. You cannot write it in the P by Q form. So it is an irrational number. It is an irrational number. Okay, because if you expand root 2, it will be like 1.14. Okay, 1.14, it goes on 1.4.1 something, it goes on, but it will never end. Okay, root 2 value, if you consider, so one like this, it goes on, so it will never end actually. So whenever it is like that, and it is not a recurring number also. So recurring means what? After some time it should repeat the same thing. So that is also will not happen, and it will not terminate. Terminate means it should stop somewhere. So both cannot happen in this case. So that is why it is an irrational number. Okay, that is why it is an irrational number. So root 2 you cannot write it in the P by Q. So now, so real numbers are the one which has both rational numbers plus the irrational numbers. The first thing, real numbers means it has both rational number and irrational number. Rational number means the one which you can write in the P by Q form. For example, 5 by 6, anything like that, you can write it in the P by Q form. Whereas an irrational number, that is like root 2 you have, root 5 you have, anything like that, it is an irrational number because you cannot write in the P by Q form. Okay, so in this chapter we try to study how to prove any number. Okay, that is, if you have root 2, how to prove that it is an irrational number. Okay, so basically whenever there is an irrational number, how do you prove that it's an irrational number? So that is one part we have. Then we have the LCM, HCF is there, and how they are connected with the their numbers. All these we have in this chapter. Okay, and proving the irrational number, it is one common question every year it will come. Okay, proving an irrational number, 2 to 3 mark, it comes every year, it will come. Okay, exercise 1.1. First mean, express each number as a product of its prime factors. So you have to write in the terms of prime factors. Okay, so 140, if I split it, what you will get 2. If I divide by 2, you will get 70. Again divide by 2, it is 35. Again I can divide by 5 now. Last digit is 5. So what I will get? 7 5 is a 35. Okay, so you have to split, or you have to divide by the prime number. So because we want the prime factors. Okay, so 140 I can write it as 2 into 2 into 5 into 7. 2 into 2 into 5 into 7. So 156, if I split, divide by 2, you will get 78. Then divide by 2, 39. Again divide by 3 into 13. So this will be the number. So 156 we can write it as 2 into 2 into 3 into 30. Next 3825. You can divide by 5 I think because 5 last digit is 5. 761 right? 25 we get. 32. Then again I can divide by 150. Then divide by 3. Then 13 I think. 13 or 17. 17 threes I will get. 7 no. Threes. So we get 3825. I can write it as 5 into 5 into 3 into 17 into 3. Next one. Next 5005. So divide by 5, you will get 1001. Then divide by 11. Hmm. Then by 13 into 7, I think. 13 into 7. So 5005, I can write it as 5 into 11 into 13 into 7. So you have to use the prime numbers to split. Or otherwise, that number at least you have to write in the prime. Is this done? We'll go to the second main. Next one, find the LCM and HCF of the following pairs of integer and verify that LCM into HCF is equal to product of two numbers. Okay. So let us take first the numbers are A and B. Okay. Now LCM into HCF, that is LCM and HCF A, whatever you will get of A and B. Okay. So that LCM and HCF, always LCM into HCF of those two numbers will be equal to the product of two numbers. Always it is true. Okay. LCM into HCF of any two numbers will be equal to the product of any those two numbers. Now, first one, 26 and 91. Listen once. Okay. So LCM, to find the LCM, first we will do the prime factorization. For 26, what you will get? 2 here, 13 you will get. So I can write 26 as 13 into 2. 91, 13 into 7. So 91 is equal to 13 into 7. Okay. So LCM and HCF. HCF will be what? Common, yeah, highest common factor. So here common between these two is 13. So this is 13. And LCM will be what? What is the common is there, you will write it once. Okay, again I repeat, LCM, what is common is there, you are writing it once. Okay, into what else is the leftover? 2 and 7, so into 2 into 7. Okay, this you have to remember. Why? Because usually they give the number like a cube plus b, another one a square into b square. You should find LCM and HCF of those two numbers. So most of the time they ask like that. Then you should be able to do. Okay, HCF will be what? Common. What are the common factors you will get? Everything you will multiply. That is the highest common factor. And what is LCM? The common factors you will write it once. Rest everything you will multiply. So that is the LCM. Okay. So LCM is 13 into 2 into 7. HCF is 13. And now how much you will get? Here 26 into 7, no, 182 will get 26 into 7. Okay. Now verify LCM into HCF is what? 182 into 13. Okay. Then product of the numbers will be 26 into 91. You will get actually 91 into 2, no, this one into 2 into 13. That is 26 into 91 only will get. So it is equal here. Direct multiplication you. So we have to verify whether LCM into HCM is equal to product of the numbers. Yeah, right. 182 into 13 is what? 91 into 26 only. And the product of numbers, it is 26 into 91 only. So they are equal. Therefore, LCM into HCF is equal to product of the numbers. This is always true, and whenever you are finding the LCM and HCF, if the product is the same thing with the product of the numbers, then it whatever you would have done, that it is correct. What are the factors for 510?
2, 5, 17.
2,
2, 5, 17.
correct?
Yes.
92.
2, 12 and 26.
So HCF will be the common factor, 2 and 2 common. So HCF is equal to 2. Okay, LCM will be equal to common, you will write it once. This is done. Remaining everything you have to multiply. That is 5 into 17 into 3 into 2 into 20. I think multiplication you will do. Okay. So if you see that 510 into 92 will be equal to LCM into HCF. That is 2 into all these numbers. Okay. Next, third one. 336 and 54. Okay. After this, do this also. A cube into b square and a square into b cube. A square into b square. For this fourth one, this also you find HCF and LCF. This number also and this one also. Okay. So 336, if you split, divide by 3, you will get 1, 1, 2. And again divide by 2. 56. 56 again divide by 2. 28. Again 28 divide by 2, you will get 14. 7. So 336, we'll get it as 3 into 2 into 2 into 2 into 2 into 7. 1, 2, 3, 4. Then what about 54?
2, 9.
2?
2 into 3 into 3 into
3 into?
3.
Is correct? Okay. So HCF will be what, Netra?
3.
Tell.
3.
Only 3. What are the common? You will get here 2 is there. Here 2 is there. Okay. Then here 3. This is 3. And here you don't have, okay, 2 so you don't have, 3 is you don't have. So what will be HCF?
6.
LCM?
2 into 3 into 2.
6 into, tell me now.
2 into 2 into 2.
2 cube?
Into 7 into 3.
3 square. Got everyone? Understood or not, Bobby? You, Sharav? Got? Okay. So, the LCM will be 6 into 2 cube into 7 into 3. Now, fourth one. We'll do the fourth one once. Will you clear this? The writing? You got?
I don't do that. See, I don't need to calculate that.
Multiplication.
Yeah.
You can do it. It's fine. It's fine. Next one, fourth question. Find the LCM of a cube into b square and a square into b square. Huh. Now a cube into b square, what are the factors? We have a into b into b. Listen here, everyone. A cube into b square, I can write it as a into a into a into b into b. Why like that? See, whenever you have the same basis, just add the powers. Okay, so 1 plus 1 plus 1 is 3, so it is a cube. And the same basis, just add the powers 1 plus 1, 2, so it is b square. Then again, a square into b square, I can write it as a into b into b. Now, what are the common factors we get here? A, another a, yeah, b into b and b into b. So, HCF will be equal to a square into b square. And LCM will be a square into b square into what else the remaining is there? A. So LCM is equal to a cube into b square. Now we will verify this ones. Okay. So HCF into LCM will be what? A square into b square. HCF is a square into b square into LCM is equal to a cube into b square. That is a square into a cube is what? 8 to the power of 5. 3 plus 2, 5. You should add the powers. Okay. B will be b to the power of 2 plus 2, 4. Okay. Now, the if you add, take the product of the numbers. So, product of the numbers will be equal to a cube into b square into a square into b square. That is a to the power of 3 plus 2 is 5, and here b to the power of 2 plus 2 is 4. So it is verified. So 12, I can write it as 2 into 2 into 3. 4 3s are 12. 15, 5 into 3. Then 21. 7 3s are 21. 3. So HCF will be 3. Common, it is 3. Okay. So LCM will be the common 3, we write it once into 2 into 2 into 5 into 7. Now you have to multiply that. So 3 into 2 2s are 4. Then 4 5s are 20. 20 into 7, or LCM is equal to 60 into 7. That is 420 you will get. Okay. Here, like that rule will not apply. A into B into C, that will rule will not apply here. Only for two numbers it is correct. That is A into B is equal to LCM into HCF. It is there only for the two numbers, not for the three numbers. Okay. So what I did, 12 find the prime factors, 15 find the prime factors, 21 find the prime factors. So common of all the three is 3. So HCF is 3. LCM will be common, you write it once. Rest everything if you multiply, that will be the LCM. Okay.
Now we have to multiply 17, 23 and
29, correct.
1, 1, 3, 3.
So HCF will be 1 because all the prime numbers, so you don't have any other common factor other than 1. And LCM will be 17 into 23 into 29.
This 1, 1, 3, 3, 9.
11339. So the LCM will be equal to 11339. Okay, the third one. Third,
HCF is
8, 2, and 25. What is HCF?
1.
1, because you don't have any common factor here also. So LCM will be
1800.
8 into 9 into 25. That is 72 into 25. How much will get?
1800.
800. Okay. HCF of 306 and 657 is equal to 9. Okay. Then find LCM of 306 comma 657. Listen once, this type of questions they will ask, and they will ask for MCQ. Okay, so we know that HCF is 9 and LCM you have to find, and we know that HCF into LCM will be equal to product of two numbers. Correct. HCF here is 9 into LCM will be equal to A into B. A is what? 306 and B is 657. So LCM will be equal to 306 into 657 by 9. I think this will be little bit easier to do. Here 9 ones, so I think here 306 will go in that. 34. So LCM will be 34 into 657. Okay. 22338. Understood, right? So whenever they give LCM and you have to find HCF, or HCF they give and you should find the LCM, you know the numbers also, then you can use this. Or sometimes what they give, HCF and LCM they will give one number they will give. So you have to find the other. There also will use the same formula. Okay. Again I repeat, sometimes they give HCF and LCM and one number they will give, you have to find the other. So that will be what? HCF into LCM by the number. You will get the other number. So these type of questions comes in MCQs. In the MCQs, you will have 2 minutes to do one problem. Like that. Okay. Right. See, when any number, when it has to end with the 0, then it should be in the form of 2 power n into 5 power m. Okay, that is 2 into 5 is 10, right? So if it is in the form of 2 power n into 5 power m, then only it will end with 0. So it is 6 power n. 6 power n means what? 3 into 2, right? 2 power n into 3 power n. So that cannot be written in this form. So it will not end. Any number if they ask, you have to do that. Maybe 4 power n also they can give. 4 is 2 power n into 2 power n. So that is not in this form. So you cannot. Okay, so n is a natural number. That means what? N you can have any number 1 to infinity, but it should be a positive integer. Okay, so here this only 2 power n into 5 power m. If it is in this form only, you will get the somewhere end will be 0. Okay, so write like that. When the number, write that when the number is in the form of 2 power n into 5 power m, then it ends with 0. Then it ends with 0. 6 power n, you can write it as 2 power n into 3 power n. Is not in the above form. Hence, does not end with 0. It does not end with 0. 3n only here, because 6 power n, no. 6 you can write it as 2 into 3. For both n is the same. So that is n only here.
25 and then
5 into 5. Like that. Okay. And write the conclusion properly so that when they see that only they should be able to understand, okay, your answer, then directly they will give the marks. Okay, because you are writing board exam, whatever is there you write the conclusion, and here also LCM is there, write the answer and just put it. So that they will know whatever the answer is there. Somewhere in the in between steps they are not able to understand also, if you write the answer correctly they will give marks there. Okay. Conclusion part also you should write. Write the notes properly during exam time. Just you read the notes, that is enough. Only difficult problems you can do. Hmm? If you don't have the notes, everything you have to do. Don't do that. Hmm? It's done. Everyone, Bihan. Next one. Explain why. Explain why 7 into 11 into 13 plus 13 and 7 into 6. 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. So what do you mean by composite number? Repeat. Which has more than two factors. Which has more than two factors. That is, it has the factors other than 1 and itself. So if 2, if I consider, it's a prime number because it has only factors 2 and 1. Okay, if I consider 8, 4 into 2, I can have. That means factors other than 8 and 1 is there. So it is a composite number. Now, you have to prove that or explain these two are the composite numbers. Okay, so first one, what we have, 7 into 11 into 13 plus 13 is there. This is one number and 13 is there. Correct? That is one number. I can take 13 common, right, in both. 13 I can take common in both. So what I will get, 7 into 11 plus 1 or 13. 7 into 11 is 77. This is 77 we will get. 77 plus 1, 76. 78. So what you will get, 13 into 78. Okay, 17 in 13 into 78. So you have factors other than the number here. That is why it's a composite number. No need to multiply. This is very important question. Many times in the exam it comes, MCQ part. Okay.
Why is it plus one? Plus one.
No, 78. That's all. See,
No, in the question, the answer is written plus one in the bracket.
where I have written plus
7 into 11. 7 into 11 plus 1.
Correct. No.
Why 1 is there?
Okay. See, 7 into 11 into 13. This is one number. 13 is another number. In these two number, I can take common. If I take common, see, common means it should be there in both. If I multiply, I will get one number. Then I can take common. Instead of that, directly only I can take the number common. No. So here also 13 is there. Here also 13 is there. Correct? If I take 13 common, what else is remaining here? 7 into 11. Plus here 13 means 13 into 1. Correct? So common is 1. That's why I've written. Okay, now 7 into 11, 77. 77 plus 1, 78. So 13 into 78. So number has factors other than the number, right? So it is a composite. Okay. So right, it has 13 and 78 as factors. Hence, it is a composite number. Hence, it is a composite number. No need to multiply and do. Okay. Here also. Next one, do the next one now. Similarly, the same way, 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. What I can take common here? 5. So if I take common 5 here, what else is remaining? 7 into 6 into 4 into 3 into 2 plus 5 into 1 here. So 5 I have taken outside, remaining is 1. Okay. 7s are 42. Huh. So you will get 5 into 1008 plus 1. So it is 5 into 1009. So here also you have the factors. So it is a composite number. Same thing. It has factors 5 and 109. So it is a composite number. And write the conclusion. You have these two factors, hence it's a composite number. Okay. In exam also, make sure you will write the conclusion part. Okay. 7th. There is a circular path around a sports field. Okay. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in same direction. After how many minutes will they meet again at the starting point? So how to calculate? So what he is telling first, like there are two persons. One is Ravi, okay, and the other is Sonia. Sonia takes 18 minutes to drive one round. Okay, one round of the field. Then Ravi takes 12 minutes for the same. That is for the one round. Now they start at the same point at the same time. So each one goes 18 minutes, the other will go 12 minutes. Now again, when they will meet,
We have to take the same.
LCM. Yeah, whenever you are having this type of question, it will be the LCM. You have to take the LCM. That is the least common multiple of these. So 18 into 2, 12 into 2, like that. So where you will get the least one, that will you will again they will meet. Okay. So LCM of, you have to take the LCM of 18 and 12. Okay. Huh. So again, I repeat, whenever they are telling, like, so again when they meet, something like that, that is the LCM problem. Okay. So 18, I can write it as 2 into 3 into 3. And 12, 2 into 2 into. So LCM will be 2 into 9 into 6. So 12 into 9. What will be the LCM? 3 is also common, no? 1 common, yeah. So 2 once we have written, 3 once we have written, then it is 6. Yeah. 2 common, 3 common, then 2 into 3 into 6. So it is 36. Okay. Whenever they ask, like, if you want to divide, think there so many fruits are there. For example, 40 fruits are there, 40 guava is there, okay, and 80 mangoes are there. Another one, 120, it may be papaya is there. You have to put it in the rack such a way that each will divide. Okay, each will divide. In this rack you should have only mangoes, then next rack it should be only govas, like that. So in a rack you should have same type of fruits, and number of fruits should be same in all the racks. If it is something like that, then it is HCF. Okay, whenever you are dividing something, it should have the same number of fruits and the same type of fruits in a rack. Something, it is basically you are trying to divide, then it is HCF. Okay, simultaneously again when it comes, then it is LCM. In this LCM also they will ask traffic signal and all. So maybe like one traffic signal comes for 2 minutes, other for 6, other for 8, something like that. So they will start at the same time, then again when it will repeat, all the three will be green when, like this also it is LCM. Understood, no? Because you are having the test, right? All of you, I'm just telling what and all type they will ask. Okay, clear? And only the remaining we will do other day. Monday we will do. And root 2, proving root 2 and all, no? They will definitely ask one problem. Proving root 2, you want that? You can do? Huh? Okay, 2 minutes we'll do it. Right down. Prove that root 2 is a irrational number. They can ask any number. It can be 11, 5, 7, everything is the same. Okay. See, yeah, whenever you are proving this type of thing, it's a very basic thing, right? What we will do is first we will assume it's a rational number. Then we come to the conclusion that whatever we have assumed is wrong. That is why we prove that it is irrational number. Why we use this method is whenever very basic things you cannot prove any other way. So that method we call it as the mathematical induction method. Okay, this type of proving. Okay. Now first we will assume root 2 is a rational number. Rational number means what? P by Q you can write. Let root 2 be a rational number. Write down first. Let root 2 be a rational number. Okay. So whenever it's a rational number, you can write it as P by Q form, where P and Q are co-prime. Where P and Q are co-prime. Co-prime means you don't have any common factor for them.
And Q is not equal to 0.
Q is not equal to 0. Yeah. So that is like 2 by 3, 5 by 3, something like that. So you cannot further divide that. That is, they don't have any other common factor. So then we call it as co-prime. Okay. So root 2 is equal to P by Q. Now squaring on both sides, what you will get? 2 is equal to P square by Q square. Okay. Or I can write Q square is equal to P square by 2. So that means what? You can divide p square by 2, you will get some factor q here, correct? So p square is divided by 2. Whenever it's square number, you can divide by 1. Okay, that means that number also you can divide. That means 3 square by some number is there. Okay, or for example 4 square by 2 you will do. Then 4 by 2 also you will get a quotient. It will be also a factor like that. Okay, therefore 2 is a factor of p square, and hence factor of p. Okay, so 2 is a factor of p square, so it is a factor of p also. So p, I can write it as 2 times c. Since you can divide, right? You can divide p by 2 and you have a 2 is a factor. So I can write p as 2 times some number c. So p square will be what? 2c whole square. Correct? So in this we'll write it as equation 1, 2. Substitute 2 in 1. So what you will get? Q square is equal to 2C whole square by 2. Q square is 4C square by 2. Or Q square by 2. I can write it as C square. So Q square by 2, we got it as C square. That means what? Q square can be divided by 2. 2 is a factor of Q square. Therefore, 2 is a factor of Q square. Hence 2 is a factor of Q. Okay, so what we got, once we got 2 is a factor of P and 2 is also a factor of Q, but what we assumed, there is no common factor. So it is a contradictory statement, right? Once we are telling it's a co-prime and once we are getting there is a common factor 2. So why it happens? Because whatever we have assumed itself is wrong. That is why root 2 is an irrational number. Okay, so 2 is a factor of P and Q, but P and Q are co-prime. This contradiction occurs due to the assumption root 2 is rational number. Hence, root 2 is a irrational number. It's a irrational number. Okay, this type of question, definite one question you will ask, they will ask even in the board exam, 2 to 3 mark. Okay, they may ask instead of root 2, root 11, root 7, root 5, anything. Usually, root of any prime number will be an irrational number. Okay, root of any prime number will be irrational.